Hello, this is Shubham. Today I'm going to deliver a presentation on large language model systems for enterprise applications. Let's start with a brief introduction of what and why are we doing this. Over the past few years, there has been a rise of large language models, and they have transformed how we see AI and how industry has been using AI so far. Large language models like ChatGPT, Claude, Llama, they are pushing the limits of natural language generation and understanding, and they are the latest models are capable of even being at par with human level conversations and understanding of language. But what are these models? These are models based on the inherent idea of transformers in deep learning. Let's get to the background of it. Where did it all start? It all started by a deep learning paper by Ashish Vaswani in that came out in 2017, titled "Attention is All You Need," which introduced the attention mechanism, which is the basis or the foundation of all the large language models or the modern AI that we use today, especially in natural language processing. In 2018, based on the attention mechanism, Google released a model called BERT. This is one of the models in natural language processing that form the basis of the advanced large language models that we see. But can be considered a large language model itself because it was trained on large amounts of data and had large amounts, billions of parameters. In 2019, Chat, uh, so if you are familiar with ChatGPT, OpenAI are the founder of ChatGPT. They are the owners of ChatGPT. And the first model of ChatGPT was released on a version of GPT-3. And in 2019, OpenAI released GPT-2, which was almost as good as ChatGPT or GPT-3 that we see today, but it lagged. It wasn't as good, and one of the changes that has happened from GPT-2 to GPT-3 is increase in the size of models and the data that OpenAI fed it. In 2022, around November of that year, I remember ChatGPT came in. It became the fastest product to reach a million and I think 100 million users. And in 2023, ChatGPT uh, upgraded to its OpenAI's GPT-4 model, which is I think around 100 times bigger than GPT-3. And also one key milestone that happened or a key breakthrough that happened was until 2023, all the large language models had sort of a closed architecture, especially the state of the art ones. But Facebook's artificial intelligence research division released a version of an open source model called Llama, and it was and so far has been at almost similar or at par with the performance of ChatGPT. So these breakthroughs have caused significant improvements or changes in other fields as well. So, like few fields that AI has managed to disrupt over the past 2 3 years has been healthcare, education, law, finance, and scientific research. So, I think all of us can like think of some applications of uh, how applications or benefits that ChatGPT has had in our daily lives. So I would rarely like I would argue that there would rarely be a person who would say that ChatGPT has not improved their productivity in their lives. So yeah, moving on. Let's look at the impact of these large language models in the industry. So first thing is it has changed how companies interact with data, customers, and internal processes. So one thing I remembered before large language models was like before they came around was that every company, every startup wanted to develop its own models because it was much feasible for those companies to do so and much more cheaper, uh, right, than using subscription based or APIs from the creators of these models, right? But ever since ChatGPT came along, it's a more so I think if I'm giving an example, GPT-4, I think it has 270 billion parameters, which is impossible for me or you to host on your laptops. So it's just impossible for like a lot of people and maybe some like small companies to do so. And even for big companies, it's very difficult to train an in-house large language model, especially because the architecture is sort of ambiguous. And until now, it's not like completely, we don't know what's exactly happening within GPT. Yeah. And also at the same time, the advent of these models has have like an effect of enabling automations of complex tasks and uh, and it has enabled companies to extract insights from unstructured data. So like before, I remember you had to have a structured, clean, formatted data that would be fed to the model, and the model would like sort of like give out something meaningful, even like even after like all that hard work. But nowadays you can just put some random unformatted text inside the large language models, and it would just clean it up and extract some sort of insights from it. And personally, I have found that the insights that it gives has like immense value, especially like in the work that I do. And yeah, so like we saw like that over these few years, these changes have happened, and it how it has like sort of improved uh, the efficiencies and functionings of a institution or an organization. So that calls for the need for having an approach of integrating these models or these systems within our systems in such a way that we are managing the cost, we are managing the timeliness, and we are managing the efficient integration of our like sort of a synergy between our systems and this is like and the large language model systems, right? So that is sort of the motivation for this presentation. Yeah. Um, so again, like I mentioned, it's important because it is crucial for an enterprise's success. And why system engineering approach? So a system engineering approach enables us to have compartmentalized, but at the same time connected components, uh, which allows us to uh, design the models or design the systems in a way where we can integrate the large language models within an institution without disrupting the functionings of our uh, other infrastructure. So this would include applying system engineering principles and enabling good management, good architecture design, infrastructure design, and the most important, like one of the most important part is testing those. And we have a diagram of OpenAI's model distillation pipeline here. So you would take uh, foundational model that has been like pre-trained. So you, for example, ChatGPT 4 is a like pre-trained model, right? And what you do is you take your own data, you take your own responses, you take sort of your own like beliefs and likings, and then you fine tune a model, and then you distill that knowledge within a smaller model. This model can be like a version of smaller, like smaller version of ChatGPT, or this model can be uh, a smaller or a different version of your in-house model. Um, Preferably, it will be ChatGPT or some other open source large language model on which this knowledge will be distilled, because this enables us to like have good um, or desired outcomes with it. Yeah. So, what is the system engineering approach for managing these AI pipelines? So we need to consider the entire life cycle of development. We need to think about the conception of the problem, then think about development and deployment. So you'd like come up with a design of the system, then you develop it, and then you have to put it out live. At the same time, you need to have some incremental changes that are like updates that are happening. Uh, and all at the same time, you have to also ensure that we are the maintaining our infrastructure around which the large language model pipeline is built. Why do this? First thing is it enables a good risk management, because like if you're maintaining it properly, uh, if one day something happens, it's less likely that you'll find it difficult to solve the problem than like having no maintenance and just going in one day and trying to solve that problem, right? And how can we do this? So we need to emphasize on documentation of our infrastructure design, our issues, our logs, our uh, flow of data, flow of API calls should be traceable, and we should iteratively develop our own infrastructure or improve our infrastructure as the other systems around those infrastructure are updating. So in this way, we can ensure that we stay in touch with the latest developments and deployments uh, of like surrounding infrastructure, uh, and make sure that we deploy our own systems in that are like cutting edge and state of the art. Um, so again, applying a system engineering approach is um, having like an interdisciplinary collaboration within our teams is something that is very crucial for system engine, like for effectively applying these principles and applying the system engineering approach to this problem. Um, for example, like an AI engineer, a software engineer, a database engineer, a DevOps engineer, and at the same time, management and engineering teams should be like working in synergy to ensure that everything goes well. So, like there are few stages to developing a a system. So the first step in that is concept development stage, and within the concept development stage, we need to do needs analysis of our system, right? So what do we need to exactly do? So first thing is we start by assessing what exactly does our organization need, right? So let's say if you want to add large language models within our enterprise, first thing we need to ask is, do we even need it? And how do we need it? How can it improve? Or will it even improve? Or is it worth putting in the money to improve so and so processes, right? And then we need to identify exact specific use case for those large language models, because this is what dictates how we are going to sort of fine tune our models. Then we need to define surrounding objectives around that task or that project. We need to have laid out performance criteria. So one of them can be accuracy or percentage error. For, let's say, we are developing a chatbot, and we need to ensure that 90%, 95% of what my chatbot says in the conversation is what it should be. So that could be one of the performance criteria while designing the model, right? And then we need to do an assessment of our existing infrastructure and resources, especially like pertaining data that we have. This is very important because, like I explained, you can't host you can't host a large language model on your laptop, right? You need a much stronger or much computationally uh, if computationally heavy machinery, and you need to do an assessment and then decide your approach. So let's say if you're going to run llama, so llama is an open source model, but you need to host the weights somewhere, and the weights of that model, the smallest version of llama weights take around 20 GB of RAM to run, which is not a lot of computers can run. So we need to like take into consideration factors like this as well. Then we come to concept exploration stage. Then what we do is we evaluate. Uh, so let's say we have our requirements laid out, we have our objectives laid out, we have our performance criterias laid out, we have like an assessment of our resources and infrastructure that we already have to host these systems, or maybe the need for infrastructures to host these systems. We have done a needs analysis of that. Now we are doing a concept exploration. So in this, we would go and like do an assessment of different architectures, different fine tuning methodologies, like different ways of fine tuning. Again, like there are so many types of fine tuning. There's like where you reaching the weights. There is one like where you can distill, there is a method called DPO, which is directed policy optimization. And then there is LoRa, which is low rank adaptation. And there are so many ways. Again, that is something an organization should research while um, while they are looking for uh, ways to um, of their optimize their strategy, optimize their organizational approach to developing these systems. They also need to analyze different models that are out there. So uh, just like this is a very not well thought out example, but let's say there's like ChatGPT and this Anthropic's Claude, and both of these have uh, different capabilities in different tasks. So if we have like requirement of a certain task to be done very good in our organization, we might need to like assess the ability to do that task by different models, right? So that is one approach that can be taken. Then we need to like think about customization uh, of the models, right? So let's say you need to retrain, you need to update, you need to upgrade, you need to look at how quick can I like switch to a different model. So these customizations are also very important when you like keep when like designing the large language models. And finally, we come to concept development stages. Last part, which is system definition. This is basically once you have decided what we want to do, and we have decided what sort of uh, tools and models that we want to use. We outline the scope and scale and capabilities of these models. We and the systems. We define different KPIs which we can use to like monitor how the progress toward those like how the system development is going by tracking the progress or expected performance of these KPIs. Then we can analyze the trade-off between like performance and cost and other factors that might be in play, right? And finally, we have like understanding of where our long-term goals are, so that we can align our short-term goals toward those long-term goals. Right. Now moving on to the challenges in system engineering while adopting large language models within an enterprise. So the first challenge is the data and computational resource management. So like I mentioned, we need enormous amounts of data to find even like to fine tune these large language models, and we don't know how much data we need to collect or have. So we should have a scalable pipeline. At the same time, we don't know how much RAM um, or GPU we might need in like coming few months. So that is an assessment that we need to do uh, while designing these systems, right? So like think we are thinking about this from the point where we are just getting started. And while when we are just getting started, don't have any idea of how much our demand is going to be or how many people are going to use it, and you can never prepare for that. But having some ideas, some surveys, something will work, should work. Again, coming to the second point, we need to look into the model safety and its ethical behavior. So have to look that we are providing special like specific guardrails and mechanisms around the model so that it doesn't go around and say something or do something that might put our organization into trouble, right? The third thing is performance optimization. Again, we need to think of ways we can uh, optimize or improve the working of our models. So, for one example, I would give is use of quantization, which basically rounds off or makes the precision of um, some So basically, AI is all numbers, matrices inside, and and if you like decrease the precision, so let's say like there are 5-digit decimal variables within the matrices, and you quantize it to like three decimal places, it wouldn't like change the performance of the model much, but it would be enormously fast or enormously efficient for the models to like do so. Again, coming back to mitigation, fairness, ethics, this again comes to ethics. We need to make sure that it's not biased and our model is fair to all sorts of not only in terms of race and gender, at the same time, it's fair in terms of thinking and ideologies, and it does not hold biases towards a particular group or a particular idea. Also, at the same time, we need to balance the generalization and specialization. So we don't want to want a model. So like to create a specialized model is much more easier to do, and to create a generalized model is much more complex, at the same time much more bigger task. And if you are like specializing like existing large language models for just one purpose, it's better that you'd rather have a model for just one purpose. So like the I would say that the modern large language models are capable of serving more than one purpose, and that's how it should be like used. And the other challenge is integration of these systems that we are designing into our existing infrastructure. This is something that I talked about earlier. And in the end, we need to have a good pipeline for maintenance, and we need to optimize our cost um, by like thinking about trade-offs of, like I said, quantization, where you lose like few percentage of accuracy for maybe like by say like, and but at the same time you save like $1 billion or maybe like $100 million over the next year. So that would be something that the firm or the organizations need to think about. So these are some challenges that have been yeah, so that's it. We are done for today. Um, moving on to this presentation, I'd I'd say that I'll improve, or I'll add on some ways how company, like some methods, some more technical methods on how companies can add the or company how companies can design these systems. So like I talked about DAPO and fine tuning, other fine tuning methods like LoRa. Um, so I would like to, or I would be compiling those methods and list of those methods into my next presentation, and make it something that can be helpful for people within the industry as well, um, to like use as a guide to actually implement these systems within their enterprises. Yeah, so I think I'm done for today. Thank you for having me.